Okay, so we're gonna take this graph paper. You can print it off of Canvas, or if not, you could draw a little coordinate plane and just make your axis go to 11 and negative 11 in both directions. But I'm gonna have you draw some ordered pairs first, and then we're gonna kind of like connect the dots so our graphs all match. So we're gonna put an ordered pair right here at -8, 0. I'm going to put another ordered pair at -5, 4. I'm going to put another ordered pair at -2, 0. I'm going to put another ordered pair at 0. Actually, hang on, I'm going to write on the other side. Hang on. I'm going to put an ordered pair at 0, -3. I'm going to put another ordered pair at 3, 1. I'm going to put an open circle, not a dot, an open circle at 8, -7. Open circle. This is 8, -7. Okay, I'm going to play, sorry, I'm going to play kind of connect the dots-ish. We're going to draw a polynomial function. So I'm going to start way up in the sky, and I'm going to come down to -8. So I'm going to start way up here, come down to -8, up to the -5, 4, through -2, 0, down to the -3, 0, and I'm going to hop back up to 3, 1, and then down to my open circle. I'm going to go back over this in a black so you can see it a little bit better. I'm definitely by no means an artist. My far left hand part of my graph has an arrow on it. So there's my graph. So I'm going to color code some key features this graph has. So the first thing I want to talk about is this dot right here, my -8, 0, my -2, 0, and this dot right here, which I forgot to have you label, sorry, right here. That dot right there is 2, 0. One more dot I forgot, sorry, I forgot these 2 dots. 5, 0. All of these red circled dots, so I'm going to put an answer key over here. You can write it on the bottom of your graph paper. The red circled dots are what we call x-intercepts. They're also called zeros or roots. It's the place where the graph crosses the x-axis, and it's also the place where my function f of x equals 0 because my y value is 0. So those are some key features. Let's use this yellow right here. This one right here, that's my y-intercept. That's where x is 0. Okay, this is where things get a little bit trickier. I'm going to circle 2 dots, this one right here and this one right here. Both of these green things are maximums. Okay, but we need to clarify a little bit. Because I have an arrow at the end right here, this arrow, my graph, oops, sorry. This arrow right here in my graph. My graph's going to go up forever and ever and ever. So both of these maximums are called local or relative. It's because I keep going up, so I don't have what we would call an absolute highest point or an absolute lowest point. So they're called relative or local. And we're going to write down that those maximums were -5, 4, and 3, 1. I'm going to go back up here just so you can write the ordered pairs down. My x-intercepts, I'm going to write them down. -8, 0, -2, 0, 2, 0, and 5, 0. We're going to grab our blue. Oh, before I grab my blue, I'm actually going to have you fill in this dot right here. Oops, wrong pen. Fill in this dot right here at the end of my graph. So make it a closed circle instead of an open circle. Okay, so I'll grab blue, different color, and I'm going to talk about, yes, this was my y-intercept, but it also has another meaning right here. And I'm going to take this closed circle right here. These things are called my minimums. The 0, -3 is a local or a relative, because compared to the stuff around it, it is a lower point. However, my 8, -7 is an absolute minimum, because it is the lowest point my entire graph touches. So again, my 8, -7 is the lowest point that my graph touches ever. So it is an absolute minimum, but there's not a relative or absolute max because the graph keeps going up forever. So everything that's a max or min is called relative. I also have one more relative min. It's this one right here. My my -8, 0. Compared to the stuff around me, that little valley is a local minimum. Okay, so the last thing we're going to talk about is what part of your foldable is called increasing or decreasing. And let me grab a new color for that. I'm going to use, we'll try a purpley color. Increasing is when you draw little tangent lines and the graph is going up. So like this is an up piece, and this over here is an up piece. So for increasing, oops, shrinking my stuff really quick so I can, for my increasing, oops, I'm going to write down the intervals, and we always use parentheses. So for increasing, I'm increasing from -8 to, we're using x values only, -5. X values only, because if I plug in any x value from -8 to -5, I'm going to be increasing. We're going to put the little union symbol, and I also increase from where my x is 0 to where my x is equal to 3. So that is my increasing. The other thing we can do is we can decrease where we go down. So that's a decreasing. That's a decreasing. And my last piece over here is decreasing. Again, we're using only the x values. So I decrease. That first piece is going forever and ever. So I'm going to go from -infinity on my x-axis to -8. Union or and. -5 to 0, union or and 3 to 8. Then I'm going to run out of colors soon. Let's see, what have I not done? I'm going to use this pink color. This last thing right here, I'm going to draw these tangent lines. Anywhere I can draw a horizontal tangent line, it's where the graph's not increasing or decreasing. So at those pink lines, it's where my graph's what we call constant. It's not increasing, it's not decreasing, it's constant. So the last piece, if you're not increasing or you're decreasing, you're constant. And the constant is not an interval. It's just at that one x value. It's the x values that we used in our ordered pair, not in our ordered pairs, in our intervals above. So for example, x equals -8, comma, -5, comma, 0, comma, 3. I'm not going to include my 8 down here at the end right there. Nope, don't include that one, because that's the end of the graph. So you don't know if I'm increasing or decreasing or constant there, because you don't know what happens after me. So we talked about x-intercepts, y-intercepts, maximums, local and relative, minimums, local and relative, where we increase, where we decrease, and where we're constant. The last thing I'm going to have you write down is the domain and range for this graph. So domain of this graph is my x values. My x's start at negative infinity, and they go all the way until 8, and then the graph stops. Because the 8's a closed circle, I'm going to use a bracket. For my range, we're going to go from the bottom of the graph to the top. So I'm going to do a bracket because I touch the -7 value, and then I go up forever. So my range is up into infinity. So this goes on the inside of your folder, but where there was the big blank space, because now that you have all these definitions, now you have a visual image to look at what these things actually appear to be on a graph.